Can you try this organic chemistry synthesis problem? So in the reactant molecule here, we have this haloalkane or alkyl halide, and the products here, we have this ether. So let's find the similarities and differences between this molecule and this molecule. So I'm going to number it like this, which is not the official nomenclature. It's just going to help me keep track of my atoms here. 1, 2, 3, 4, 5. And let's say that these 5 carbons here are the exact same 5 carbons as these 5 carbons right here. And we do see extra carbons here. So let's keep going. 6, 7, 8, right? And we see a new carbon to carbon bond is formed right there, which is a big key indicator of a Grignard reaction. So we know that we can make a Grignard reaction to create that new carbon-carbon bond where we can have MgBr, and one of these carbons here will be the nucleophile, one of the carbons here will be an electrophile, right? Looking at the reactant molecule here, carbon 5 could be the nucleophile because we could make this into a Grignard reagent by adding magnesium with diethyl ether to give us this Grignard reagent here. And this is the star, aka the nucleophile here. This is going to be the dot, aka the electrophile right there. And we see directly attached to the dot or electrophile is an oxygen atom, which we can say came from an alcohol. And we could convert the alcohol into an ether using Williamson ether synthesis. So we could use these two reagents here. First step, NaH to deproteinate the alcohol to create the nucleophilic alkoxide ion, which will then attack this carbon and kick out the iodine in an SN2-like fashion to give us this ether here. Now we know that we want to create an alcohol here, where we know this is the starred carbon, which is this exact same carbon here. This is the dot carbon, and we're trying to make that new bond right there. And we know that we could do that with the alcohol here, saying that this alcohol came from a carbonyl, a carbon double bond oxygen. So in the first step here, we can copy and paste the exact R group, which we can do in synthesis. And this carbon here has a hydrogen, which I'm going to draw out like that, which is an aldehyde. And then when this Grignard reagent affects this carbonyl carbon, we pop the double bond onto the oxygen, giving it a negative charge, which we can get the neutral alcohol by protonating with an acidic source like hydronium ion, H3O+, like that. So in summary, we formed the Grignard reagent and we reacted that with a carbonyl with acid workup. And then from there, we did Williamson ether synthesis from the alcohol to create the ether here. DM or comment organic for a free organic chemistry tutoring session from me.